Okay, I'm back. We are going to finish up this Unit 6 review. All right, so number 15, we're trying to figure out which of these pictures could match this graph. All right, well, first of all, I know a square root graph is not a full parabola. That is an x squared graph. He's out. And I know a square root graph does not have two sides like this, making a sideways parabola. That would happen if I had a positive square root and a negative square root, but I don't have that, so this one's out. Okay, now I could easily just put this in my calculator and look, but I know that because this is positive, there's no negative in front, that this graph is going to go upward. Whereas if it would have had a negative in front, then it would open downward. So I know it can't be B because that would have had to have had a negative before the square root. So I know the answer C. But sometimes people don't believe me. So I'm going to go ahead and just put it in my calculator. 3 square root of 2x plus 2. And I'm going to hit graph. And you can see it opens upwards. It does not open downwards. And it is not a full parabola, and it is not a sideways parabola. So C is our answer. Okay, 16, we are finding the inverse. All right, so inverse is when the x's and y's switch. So remember, f of x is just a fancy y. And so the first thing I'm going to do is I'm going to switch my x and my y. So my y is going to switch to an x, and my x is going to switch to a y. So flip-flop. All right, now my goal is to solve for y. All right, so I need to get this square root by itself before I can get rid of the square root. So looking on the side with the square root, I have this subtraction of 3 that needs to go away. So to get rid of subtraction of 3, I do the opposite and add 3. This zeroes away. So all I'm left with is the square root of y minus 1. And on the left side, you can't actually add these together because they don't both have x's. So x plus 3 is just x plus 3. Okay, and for the third time, to get rid of a square root, you square. And if you square one side, you square the other side. Okay, on the right side, the squared and square root cancel, so all you're left with is y minus 1. And on the left side, I need to do a little math. So x plus 3 squared means x plus 3 times x plus 3. Anytime you square something, it means take it times itself. And I'm going to FOIL or double distribute this out, whatever words you like. So first I'm going to distribute the x with everybody in the back. So x times x is x squared. X times 3 is 3x. Now I'm going to distribute the 3 with everybody in the back. So 3 times x is another 3x. And 3 times 3 is 9. Okay, then I can combine like terms. So if I can combine a 3x and a 3x, I get a 6x. So x squared plus 6x plus 9. Okay, so that's what this makes. So I'm going to put x squared plus 6x plus 9. Okay, and then to get y by itself, I only have one more little thing to do. And how do you get rid of subtraction of 1? You add 1. And I can only add it to the 9 because those are the only people that are like terms. All right, so the y is by itself. And then the x squared drops. The plus 6x drops. And 9 plus 1 makes 10. And that is my final answer. And so that is answer choice A. Now, I really do know that there is a little bit more to this problem, but without graphing it, we're just going to be happy with this answer right here. Okay, 17. There are a few different ways to do this. It says to determine whether this and this are inverses or not. I'm going to do it the way I think is the easiest. So I am going to put this into y1 and go to my table. Okay, so I am making a table for f of x right now. Let me just put that here. All right, so I'm going to go to my y equals, and I'm going to put in square root of x minus 7. And then I'm going to go to my table, and I'm going to look for the first spot under the error. And there it is. So I'm going to put just 3 nice numbers, 7, 0, 8, 1, and 11, 2. So 7, 0, 8, 1, 11, 2. 7, 0, 8, 1, 11, 2. Okay, now I'm going to do the inverse. So earlier I said something about inverses switch around the x and the y's. So this point switches. So I do the flip-flop, the flippity-flop. So when you flip 7, 0, you get 0, 7. When you flip 8, 1, you get 1, 8. When you flip 11, 2, you get 2, 11. Okay, this is what the inverses table should look like. Well, it wants to know if g of x is the inverse. So what I'm going to do now is I'm going to put g of x into my y1 and see if these points are in its table. So let's look. Okay, so I've got parentheses, x plus 7, close it up, and square it. I'm going to go to the table, and I'm searching for 0, 7. Let's see. 0, 7 is not there. So if one of the points is not there, then there's no way they can be inverses. All 3 points would have to be in the table for them to be inverses. So this is a no. Okay, we are cruising. Okay, next step, number 18. Okay, we are to solve this equation. Okay, so we've done something kind of like this already. So to remind you, we need to get the parentheses with the fraction exponent by itself. So I need to get rid of the 4, and I need to get rid of the minus 6. Well, we tend to get rid of addition, subtraction first, typically. So I'm going to get rid of subtraction of 6 by doing the opposite and adding. So that zeroes away. 2 plus 6 is 8. And then I'm just going to drop everything on the left. Okay, so I'm still trying to get everything in parentheses that's raised to that fraction exponent by itself. So now how can I get rid of the 4? Well, I can't distribute it because of the exponent. If the exponent wasn't there, sure, I could distribute. But because of the exponent, you can't do that. So since the 4 is smushed with the parentheses, it's multiplied. So to undo multiplication, we divide. So 4 divided by 4 is 1, so those just cancel out. So all you have remaining on the left side is parentheses 2d plus 3 raised to the 1/3. And on the right side, 8 divided by 4 is 2. Okay, so now to get rid of the fraction exponent, we take it to the reciprocal exponent power. So flip 1/3, flip, and you get 3 over 1. So I'm raising this side to the 3 over 1, so I'm going to raise this side to the 3 over 1. However, 3 over 1 is the same thing as 3. So these just make 1. So shoop, shoop. All you're left with is 2d plus 3. And on the right side, 2 to the 3rd, 2 times 2 times 2 is 8. And now the rest of this is easy peasy. Just a little 2-step equation. Get rid of addition of 3 by subtracting. So 3 minus 3 zeroes away. Your 2d comes down. 8 minus 3 makes 5. And then how do you think you would get the d by itself? Divide. So we're going to divide both sides by 2. And I can't divide 5 by 2. I can't reduce it, so I'm just going to leave it. And it does say, if necessary, type your answer as a fraction using that key and no spaces. So We're going to leave it as a fraction. Okay, number 19. I'm going to show you two ways to do this. So what should I do first? Easy way? Okay, I'll do easy way. So the easy way, of course, would be with the calculator. So I go 8, and then above the division bar is your little caret. And then I'm raising it to the 2/3. So I could do alpha y equals here, I guess. Maybe that would be the best thing for you guys. So alpha y equals, hit my enter, 2 on top, arrow down, 3 on bottom, and the answer is 4. So that's the answer. Now, to practice something that we have kind of already talked about, this is exponential form, and I'm going to put it in radical form. So whatever the denominator is, that is its root, and whatever the numerator is, that's its power. Okay, so another way of writing that is to take the cubed root of 8, and instead of putting the power of 2 here, I put it like on the outside. So this is telling me to take the cubed root of 8. So what times what times what makes 8? 2. 2 times 2 times 2 is 8. And then I'm going to raise that to the second power. And 2 squared, 2 times 2 is 4. I'm sure you all like the calculator better. Okay, number 20. This is the square root. Now, let's just see if we can take the square root of 450. We cannot. Okay, so we need to be thinking about all of our perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15, etc. I need to find the biggest number in this list that can divide into 450. Well, that 225 is kind of staring me in the face. Now, it might take you guys a little bit longer to find it, but there it is. 225 goes in there twice. Okay, so I'm going to rewrite it as square root of 225 times the square root of 2. And then what is the square root of 225? Well, if you don't remember, you can put it in your calculator. You get 15. And then you can't take the square root of 2, so that recopies. All right, now let's deal with those letters. We are looking, since it's a square root, for groups of 2 or for pairs. So if you have 15 x's, how many groups of 2 would that be? It'd be 7 groups, and there'd be 1 left over. So I'm going to build my square root, get my 2 back in there, and put my leftover x. And then if you have 12 y's, how many groups of 2 would that be? Exactly 6. And this is my answer. 15 x to the 7th, y to the 6th, square root of 2x. Do we see it? Nope. Yep. There it is. So when you do square roots, you're looking for groups of 2. When you're doing cubed roots, you're looking for groups of 3. All right. Now, 21 looks very intimidating. We really just need to know 2 rules here. First of all, there is nothing to multiply that 7 with other than the invisible 1. So 7 times 1 is 7. So I am ignoring the denominator, okay? He's not even there. Can't even see him. If this is all I saw, all I need to know is what's the rule that I'm going to use for the exponents. I'm going to add. When you multiply same bases, add exponents. So I need to add these exponents. Okay, so 3/5 plus 2/5 is 5/5. You could always put it in your calculator. Now I know that reduces to 1, but I'm actually going to leave it like that. Oops, there should be an x. I keep doing that. All right, so whenever you multiply the same base, you keep the base and you add the exponents. So 3/5 plus 2/5 is 5/5. Now I'm going to put my division bar back and my x to the 4/5. So I have nothing to do with the 7, so I just recopy it. Now you just need to know what's the rule for exponents when you divide. When you divide, you have to subtract. So 5/5 minus 4/5 is 1/5. And that would be my answer. 7x to the 1/5. And so that is answer choice A. Okay, I'm getting closer to being done here. Okay, it is asking us to put this in radical form. So I've already talked about this. Radical form, you need a radical. Whatever the denominator is, that's your root. And whatever your numerator is, that's the power it's raised to. And so x goes here and 3 goes here. And so if we look, it is answer choice A. Okay, 23. I am trying to add and subtract these radicals. Well, you cannot add and subtract radicals unless you have the same number under the radical. And right now, none of these are the same number. So I need to simplify all of them. So they're square roots. So let's think about perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, etc. So what is the largest perfect square that can go into 12? 4. How many times? 3 times. Okay, and then what is the square root of 4? 2. So 2 square root of 3. Okay, now let's break down the 18. So who is our largest perfect square that can go into 18? 9. How many times? Twice. Okay, it's got a minus in front, so let's put the minus. And then what's the square root of 9? 3. And then you can't take the square root of 2, so recopy. Okay, now we're going to break down our square root of 50. So do you know who the largest perfect square is that can go into 50? 25. How many times? Twice. And then I'm going to bring down the plus 3 that's in front of it. And then what's the square root of 25? 5. Recopy the square root of 2, bring down your plus 3. Well, all of these are smushed, so that means we're multiplying. So 3 times 5 is 15. So 15 square root of 2. Okay, and last little guy, breaking down the square root of 75. Who is our largest perfect square that can go into 75? It is 25. How many times? 3 times. Okay, and then what is the square root of 25? 5. And then you can't take the square root of 3, so you recopy. Okay, so now I have some things that look alike. This is the square root of 3, and this is the square root of 3. So I can add and subtract as long as they have the same number underneath. So 2 square root of 3 plus 5 square root of 3 makes 7 square root of 3. So when you add and subtract radicals, you only add the front numbers. 2 plus 5 is 7. The radical just recopies. Okay, and then these are both square roots of 2, so I can combine those. So you're basically just doing front numbers. Negative 3 plus 15, well, that's 12. And the square root of 2 just recopies. And that's my answer. 7 square root of 3 plus 12 square root of 2. And that is answer choice A. Okay, number 24. I'm trying to square that. Well, squaring something means take it times itself. So square root of 13 minus square root of 3 times square root of 13 minus square root of 3. Okay, so I'm foiling this or double distributing it, however you like to think of it. So I'm going to distribute the square root of 13 first. So square root of 13 times square root of 13. Well, anytime you take a square root times itself, that number gets to slip right on out of the radical. Now, if you multiplied it and got square root of 169, that's fine, but the square root of 169 is 13. Okay, then square root of 13 times square root of 3. Since the 13 and the 3 are both under the square root, then we can actually multiply the numbers together. So it'd give us square root of 39. And it's a positive times a negative, so it's a negative. Okay, now let's distribute the negative square root of 3. So once again, they're both under the radicals, so I can multiply them. And square root of 3 times square root of 13 is the square root of 39. And a negative times a positive is a negative. Okay, now negative square root of 3 times negative square root of 3. Well, a negative times a negative is a positive. And square root of 3 times square root of 3 is 3. If you take a square root times itself, shoop, that number slips right on out of the radical. And if you wanted to write down square root of 9, it's okay, but the square root of 9 is 3. All right, combining like terms. So let's start with the pretties. 13 plus 3 is 16. And now let's combine the radicals. Since they're both square roots of 39, I can actually add them or subtract them. And remember, if you don't see the numbers in front, they're ones. Well, like up here, when you add and subtract radicals, you only work the front numbers. So I'm only working the front numbers. Negative 1 minus 1 is negative 2. And then the square root of 39 just recopies. And that's my answer. 16 minus 2 square root of 39. And it is A. Last one. So exciting. And it's an easy one. It says to use a calculator to approximate cubed root of 160 to 3 decimal places. So I do know that a lot of students have rounding issues. So let's put this in our calculator and see what we've got. Cubed root, so I'm going to go to math. And then I go to number 4. And then I type in 160. I'm just going to write down a bunch of these numbers. I'll just write them all down. Only takes a second. Okay, so when it says round to 3 decimal places, that means you go to 3 numbers to the right of the decimal. 1, 2, 3. And so then you have to look behind that number to decide whether this rounds up or stays the same. So if this is 5 or higher, this rounds up. If this is 4 or less, this stays the same. So since it's 5 or higher, it rounds up. So that 8 rounds to a 9, and everything to the left stays the same. And that is your answer, rounded to 3 decimal places. And that's it for this review. Good luck on your test. Smiley face.